Picture this, your gleaming subsurface base carved into Europa's ice shell, mining water for fuel and life support while Jupiter hangs overhead like a cosmic guardian. Clean, simple, self-sufficient. Except 3 months in, your habitat walls are flexing, your drill bits are melting themselves, and that convenient ice you're standing on just became your biggest enemy. The physics of Europa don't care about your spreadsheet. Let's start with the ice itself. You're not drilling through a frozen lake. Europa's surface sits at -170°C, but that ice isn't stable or uniform. Tidal forces from Jupiter knead the moon like dough, creating stress fractures that run kilometers deep. Your tunnels cut across these fracture zones. Every 12 hours, Europa completes an orbit and those stresses shift. Your walls flex, hairline cracks appear in your habitat seals. Now you're fighting a leak in an environment where exposed skin freezes in seconds and your air supply is everything. But the cracking ice is just announcing the next problem. Your mining operation generates heat, lots of it. Drilling, melting, processing ice into water and oxygen all pump thermal energy into the surrounding ice. On Earth, that heat dissipates into soil and air. On Europa, there's nowhere for it to go. The ice around your base starts to melt and refreeze in unpredictable patterns. You get void spaces, sudden collapses. Your foundation literally shifts beneath you. And because you build underground for radiation protection, you can't see the structural damage forming around you until a tunnel implodes. The temperature problem connects directly to your power supply. You need enormous energy to keep your base warm, run life support, and power the mining equipment. Solar panels on the surface get fried by Jupiter's radiation belts. Nuclear reactors need heat rejection, but you can't dump waste heat into ice without destabilizing your entire structure. Every kilowatt you generate either melts your foundation or forces you to build massive radiator systems on the deadly surface. The energy equation doesn't balance, and now you're discovering the radiation shielding you thought the ice provided isn't nearly enough for long-term habitation anyway. So what actually works? First, you don't go subsurface at all. You build a mobile surface station on legs or skids that can relocate when the ice beneath becomes unstable. Your habitat sits in a heavily shielded module, not carved ice. You mine remotely using tethered drones that process ice at a safe distance and pipe the water back. This separation means your heat signature doesn't compromise your foundation. Second, you design for redundancy. Multiple small habitats instead of one large base. If tidal stress cracks the ice field under Habitat B, your crew evacuates to Habitat A, while robots build Habitat C on stable ground. Third, you accept that this isn't a colony, it's a rotating outpost. Crews stay 6 months maximum, matching the radiation exposure limits we use for spacecraft. You're not settling Europa, you're operating an extraction platform that happens to orbit Jupiter. The fantasy version shows a cozy ice cave with LED lighting and hydroponic gardens. The working version looks like an industrial oil rig perched on a glacier, ugly but functional, surrounded by a graveyard of abandoned sites where the ice won. Which one actually brings your crew home? That's the difference between science fiction and science engineering. Drop a comment with the next impossible sci-fi base you want stress tested.